This video presents an edge computing application used as the input use case, providing the virtualization of a set-top box. The steps that will be described are the creation of a service template, the service instantiation, the usage of the application at home and in mobility, the usage in presence of a security physical network function, and the lifecycle of orchestration of service instances. The service provider creates the application template by using the input dashboard to define the service chain of the application and specify which modules will be connected to the user personal network or to backend networks. The dashboard is the same as OpenStack for ease of usage, but some extensions have been applied to allow the definition of input-specific parameters. The first operation in the definition of a service template consists in the creation of the backend networks used to interconnect the service subs that need to exchange data, and can be either shared or encrypted. In the following, the needed service instances will be selected and bound to such backend networks. The service provider proceeds with the creation of 5 additional backend networks, for a total of 6 as required for the proper interconnection of all the service subs composing the virtual set-top box service. Backend 2 is encrypted because it hosts the security network function that will be described in step 5. Each backend network has an associated subnet and no additional attributes. Once all the backend networks have been created, the service provider can proceed with the addition of the virtual machines that compose the service chain. The first service instance to be created is the edge storage. First, the desired flavor is selected, and then the virtual machine is associated to the backend networks 5 and 6. The definition of a proximity class and the possibility of making a virtual machine multi-user are some of the extended service requirements that have been added to the input dashboard. This particular instance is shared among 10 users because it provides a content delivery network functionality. The second instance added to the service is the edge acquirer that is connected to backend networks 4 and 6. Just like the edge storage, the edge acquirer is also shared among multiple users and does not have strict proximity requirements. Then, the personal acquirer instance is associated to the backend networks 1 to 4. This instance, along with the next ones, is not shared as they represent the actual personal service. The digital media server is connected to the user personal network into backend networks 2 and 5. The proximity requirement is very restrictive for this virtual machine. Next, we have the addition of the digital media controller that is associated with the user personal network into backend network 3. This instance has strict proximity requirements as well. And finally, there's the addition of the virtual decoder interface. In the following of the video, we will see that this virtual machine and the digital media server will be the ones to be migrated upon user movement. In fact, they are the ones with proximity class set to 1. After the service chain configuration is finished, the service is made available to the user for subscription. When a user subscribes to the virtual set-top box service, The OpenVolcano interface of the telco operator displays the occurred subscription by means of the created user and related multi-center personal network. The top right map shows the data center in which the virtual home gateway instance has been placed, while the bottom right map shows the logical view of the overlay network centers. The user can subscribe to the personal cloud services by using the virtual home gateway web interface offered by OpenWRT. In this case, we can see the subscription to the virtual set-top box service of which we've just seen the template creation. Upon completed subscription, the placement of the virtual machines composing the service and related backend network is shown on the physical and logical maps of OpenVolcano. We will now show the behavior of the multimedia use case when the virtual set-top box is used in the domestic environment. The first operation the user has to execute is to access the input virtual set-top box user app with his smartphone. Then, he selects a video content provider. The user decides which channel he wants to watch and selects Smart TV as the output device for the service. The content stream is displayed on the Smart TV. During the streaming, the user app can be exploited for pausing and resuming the video. In order to show how the multimedia use case performs in mobility, the user now switches his connection to the 4G input test network, just like he would do if he was leaving his house. This operation is visible on the zoomed screen of his smartphone. As soon as the smartphone connects to the Node B on the left, the LTE PC web interface shows the related messages that are exchanged during the connection. The user now connected to the 4G mobile network opens again the input virtual set-top box user app. This time, he selects Play on smartphone as output for the video streaming. When the user moves closer to the Node B on the right, the handover event is shown in the messages displayed by the EPC web interface. The video stream proceeds without interruptions during the handover. Once the handover request is detected by the S1 AP monitoring VNF, the new user position is displayed in the physical view shown in the top right map. The user handover requires the migration of the virtual decoder interface and digital media server from the data center in the bottom left corner to the one on the right. The NetFPGA used as security physical network function has been integrated in the OpenVolcano data plane and exposed on the virtual set-top box service template. The NetFPGA board is compliant with OpenFlow 1.3 and as such can be controlled by Magma. The flow table shows two flows, the first with MAC address ending with 1 that has an encryption and decryption rule. the other one with the address ending in 2 that is not encrypted. When the decryption rule is removed, the encrypted flow is not recognizable by the player, and the video streaming stops. It resumes as the decryption rule is added again to the flow table. We have run some further tests to show what happens at packet level. A traffic generator is used to transmit two flows to the net FPGA. The one with the MAC address ending with 1 is encrypted, the other one is not. The packet's payload is designed to be incremental to show the encryption operation when captured. The generated payload is the same for both flows. Traffic is sent from the traffic generator to the net FPGA that retransmits it back. We use the capture tool to show the content of the received packets. The capture view shows that packets belonging to the first flow have been encrypted by the net FPGA. Instead, the packets belonging to the second flow haven't been encrypted, and in fact the payload is still incremental. This final step shows how the service deployed for one user can be modified without affecting the original template. To this goal, the service provider can use the Network Topology tab to access an individual user's subscription. Modifications on the service chain that is now visible will only affect the selected user. In this example, the edge storage instance is deleted. There could be many reasons driving this modification, spanning from a service upgrade to the need to instantiate a lighter virtual machine for horizontal scaling purposes. As we can see, the service template has not been changed upon the edge storage instance deletion, that in fact has affected only one user. The original edge storage instance will now be replaced with another virtual machine. The procedure is the same as in the service template creation shown in step 1, with the selection of the virtual machine instance, the flavor, the binding to the backend networks 5 and 6, and finally with the specification of the metadata regarding the number of users and the proximity class.